I'm going to add and subtract square roots. Square roots that have the same radicand, and remember, radicand is that number that's under the radical, are called like square roots. Now, that's super important for you to know what a like square root is, and I'm going to point this out to you throughout this video. Called like terms because of what is under the radical side. Notice the exact same thing is under the radical, which is a 2, okay? That means that we're allowed to do the operation that's going on in the problem. So 2 square roots of 2 take away 7 square roots of 2. The only thing that you're going to subtract here is the terms in the front of the radical, all right? Do not touch what's under that radical. That doesn't change. It's like the same thing as if you were to have an x there, okay? All right, so what is 2 minus 7? It is -5, and then we don't change what's under the radical. This is our final answer. Radicals here, so like terms, and we can add, in this case, the coefficients that are out front. So 3 square roots of y plus 4 square roots of y gives us 7 square roots of y, and that's it. Notice that what's under the radical here is an x, but what's under the radical here is a y. So we don't have like terms that we can combine here. So the best we can do is just rewrite this. If instead you said can't be simplified, that would be fine with me. And of course, in your homework, I think that they would expect you to just retype the problem in because there's nothing you can do here. This is as simplified as it gets. Terms. Sometimes you have more than 2 terms, and in this case, we have all like terms because what's under the radical is 13 in each one of them. So we would use our order of operations, and we would do this addition in order from left to right. So 5 plus 4 is 9. 9 plus 2 is 11 square roots of 13. That's it. Have like terms here and here, okay? So that's all that we're going to be combining. This guy just gets to follow us along until the very end, okay? So since we have like terms, we can go ahead and do 2 minus 6, which is -4 square roots of 6. And I'm just rewriting this. And we can't combine these because they are not like terms. Got under the radical 5n, 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 so we're good here. Every one of these we can combine. So 2 minus 6 is -4. -4 plus 4 is 0 square roots of 5n. But what happens whenever you multiply 0 times anything? It goes away, right? So our answer would just be 0. Have like terms to combine. Under the radical here is 3xy. Under the radical is 3xy. Under the radical is 3xy. Yeah, we totally do. Okay, so here's the thing that people usually forget. They forget that there's an understood 1 out front of this. So if we had just plain old x, we've got a couple of understood 1s here. We've got a 1 there, we've got a 1 there, okay? So understand that if you have a radical symbol, and there's nothing in front of it, there is an understood 1 to be there, okay? There's an understood 2 right here. That's why we call it a square root, okay? We don't usually write that 2, and we don't usually write that 1, but they are there. All right, so I'm going to go ahead and write it because it might help you remember that we need to do, let's see here, 1 plus 5, which is 6. 6 minus 4 is 2. So we have 2 square roots of 3xy, and that's it. But first we need to simplify this. So the square root of 20 looks like we can make that 4 times 5, right? And I could take the square root of 4, which is 2. So I have 2 square roots of 5. And don't forget, we have a plus 3 square roots of 5 here. I'm just going to bring that down. Now we have like terms, don't we? All right, so we can add the 2 and the 3 together and we get 5 square roots of 5. There we go. By the way, if you're grabbing your calculator and doing this, most calculators do not simplify radicals, okay? And this is the form I want to see your answer in. I don't want to see your answer as a decimal. I'm asking you to simplify radicals at this time, not estimate radicals. So let's talk about perfect square numbers that can go in this. Let's see here, 48. I think 16 goes in there. 16 times 3 minus the square root of, and a perfect square number that goes into 75 is 25 times 3. I could take the square root of 16 and 25, so I have 4 square roots of 3 minus 5 square roots of 3, and then 4 minus 5 is negative 1 square roots of 3, or you could simply write this as negative square root of 3. Either one of these answers would be fine for me. And by the way, this one is the most simplified version of it. All right, so in this form, there's really not much I can do with this, okay? So let's simplify this and let's simplify that, all right? So we've got 5 times the square root of an 18. I can turn that into 9 times 2 minus 2 square roots of, and I can turn 8 into 4 times 2. And then I could take the square root of 9 and 4, right? But don't forget that whenever I take the square root of the 9, I'm not just going to put that 3 out here and this become 53. That's not true, okay? What this is 5 times this. So we would have 5 times 3 on the outside because I took the square root of 9. And what's left over on the inside is the square root of 2 minus, and then over here I've got 2 times the square root of 4 is 2, and then what's left over is the square root of 2. I'm going to go ahead and do the multiplication there. 15 square roots of 2 minus 4 square roots of 2. And then I can do this math. 15 minus 4 is 11 square roots of 2. Okay, so that's it. By the way, if you wanted to check your work on a calculator, just to see if what you end up with matches what's up here, you can type this whole thing into the same calculator I've been teaching you with this whole time. You could type in 5 and then hit the second button and then hit the x squared button, and then you'll type in 18, but then you'll want to hit the close parenthesis, okay? And that button is just above the 9, all right? Because then that says, hey, we're moving on past this radical, and now we're going to do some more math, okay? So then hit your minus button. You would hit 2, then second, then the x squared button, and then 8, and you can or cannot type in that close parenthesis there. When it's at the end of a mathematical sentence, the calculator doesn't really care if it's there or not. It won't change your answer as long as it's at the end of the mathematical sentence, okay? And then whenever you hit enter, you hope you end up with the same answer you would get if you typed in 11 and then second and then the x squared button and then 2, and then enter. Okay, and on my calculator I ended up with the same answer. It was like 15 point something. All right, okay, so you can check your work, but it will not simplify. This calculator will not simplify to this form right here. It'll only give you an estimation with the decimal. This problem I thought was a little bit tougher, not because of the fractions, but because I couldn't see right away what the perfect square numbers that came out of 192 or could divide into 192 and 108. So here's what I did. I made a tree. I made a factor tree, and I know that because it's even that 2 goes in evenly, So I made my factor tree. 192 divided by 2 is 96. And I circle my primes, okay? And so 2 is prime. And so now I could keep going with my factor tree. So I'm going to write 192 as a product of prime numbers, all right? So then I've got 2 and 48. 2 is prime. 2 and 24. 2 is prime. 2 and 12, 2 is prime, 2 and 6, again, 2 is prime, and 2 and 3, and 2 and 3 are prime. So I know this can be written as 2 times 2 times 2 times 2 times 2 times 2 times 3. Okay, so what I have under the radical is 2 to the 6th power times 3. Okay, I have not taken the square root of that yet. That's okay, we're moving on. So 5 over 6 times, and I'm going to do the same thing with 108, okay? If you haven't written this down yet, or if you need to, you might want to hit pause at this point because I'm going to erase it and do the same thing with 108. You can always rewind if you have to. All right, so 108, I've got 2 and 54. 2 and 27, and then I've got 3 and 9, 3 is prime, and 3 and 3, both 3's. Okay, so this can be written as 2 squared times 3 to the 3rd power, right? Okay, now I can take the square root of 2 to the 6th power. That's like saying I have 6 shoes in my closet. They're all shaped like 2's, okay? How many pairs do I have? Well, I've got 3 pairs, right? So I've got 3/4 times 2 to the 3rd power, because remember I had 3 pairs, and then what's left over is the square root of 3. And now I can take the square root of 2 squared, which is 2. I can take the square root of 3 to the 3rd power, but that's 3 square roots of 3. Remember, I've taken 2 of them out, but I have 1 left over underneath the radical. And I'm going to multiply 3/4 times 8. That's what 2 to the 3rd power is. 2 to the 3rd power is 8. 3/4 times 8 is 6. Okay, if you're not comfortable with that, remember 4 goes in there once, 4 goes into 8. I'm just going to consider that an 8 twice, and then 3 times 2 is 6. Okay, so 6 square roots of 3 is what is right there. Minus 5 over 6 times 6. That's what that is, right? Okay, and so the 6's would cancel, and I'm left with 5 square roots of 3 right there. Okay? Now, since I have like terms, I can go ahead and do the operation out here. So 6 minus 5 is 1. You could say 1 square roots of 3, or you could just simply say the square root of 3 is your final answer. And that's it. One. Let's see here. So we've got 2/3 times the square root of, and I can rewrite 48 as 16 times 3 minus 3/4 times 4 times 3. And I can take the square root of 16 and 4. So I've got 2/3 times 4, that's what the square root of 16 is, minus 3/4 times 2, and then I've got square root of 3 left over. And now I'm going to go ahead and multiply these guys. So 2/3 times 4. I can't reduce anything, so I just multiply straight across. Remember, this is the same thing as 4 over 1. So this would be 8 over 3 square roots of 3 minus, and I can reduce that, so that would be 3 over 2 square roots of 3. Now I need to combine, because we do have like terms, I need to combine the coefficients of these things. Okay, so in order to do that, 8/3 minus 3/2, I need a common denominator. Really hope you guys have not forgotten how to find a common denominator. Let's see here, multiply that by 2, so I gotta multiply that by 2, multiply that by 3, so I gotta multiply that by 3. And so 16 minus 9 is 7/6 square roots of 3. That's it. With this in the form that it's in, because 18 and 32 don't match, right? So let's go ahead and simplify both of these and we'll see what happens. All right, so 18 can be written as 9 times 2, and then into the fifth. If you want to write it like this, you can, or you can just leave it as into the fifth. We have minus 32 can be written as 16 times 2 into the fourth n. Okay, so I'm going to take the square root of that and that and that and that. So I have 3n squared, and what's left over is 2n. I've got, let's see here, 4n squared, and what's left over is 2 and n. Now I have like terms, and notice out here I also have like terms, so I can go ahead and subtract these. So I would have negative 1n squared, or you could just say negative n squared, square roots of 2n. All right, for this problem, we can't do much with it in the form that it is in right now because we don't have like terms. So let's go ahead and simplify and hope that we get like terms. Okay, so 9 square roots of 50 can be written as 25 times 2 times m squared minus 6 times 16, square root of 16 times 3m squared. All right, I'm going to take the square root of this and that and this and that. Okay, so what we have left over is 9 times 5m on the outside, square roots of 2, minus 6 times 4m, and what's left over is 3. And now I can multiply those and multiply those. I'm left with 45m square roots of 2 minus 24m square roots of 3. And I don't see that we can do anything else with this because square root of 2 and square root of 3 are not the same. So it looks like this is actually as good as this answer gets. Last problem. Okay, so let's see what we can do here. Let's simplify as much as we can, okay? So 2 square roots of 4 times 2 times x squared minus 5x square roots of 16 times 2 plus 5 square roots of 9 times 2 times x squared. Okay, I'm going to circle all the things that I'm going to take the square root of. Take the square root of that. I'm going to take the square root of that, that, and that. All right, so this first one, I've got 2 on the outside, so it's going to stay there. I'm going to take the square root of 4, which is 2. Take the square root of x squared, which is x. And then what's left over in this one is the square root of 2 minus 5x times square root of 16, which is 4. And then we've got square roots of 2 plus 5 is on the outside already. I'm going to take the square root of 9, which is 3. I'm going to take the square root of x squared, which is x. And what's left over is the square root of 2. Now let's go ahead and multiply things out. So I've got 4x square roots of 2 minus 20x square roots of 2 plus 15x square roots of 2. Okay, now check this out. We've got like terms, and all of these guys have x's, so we can combine all of these. So 4x minus 20x is negative 16x. Negative 16, I'm sorry, Yeah, negative 16x plus 15x is negative 1x, or just negative x square roots of 2. There we go. Okay, that's it for this lesson. Again, you guys know how to reach me if you need any help, and have a great day.